So, class, we've been talking about molecules and compounds and how a molecule is a particle that has more than one atom. A molecule can be a particle that makes up a pure substance like oxygen, O2, hydrogen, H2, even some other, possibly even gold and other elements that might have similar molecules of that element bonded together. But molecules can also make up compounds, and they make up compounds when a molecule is made up of atoms of at least two or more different elements. So this is paragraph I think this is paragraph 12. So let's mark this paragraph 12, and then let's read it, and then I'll show you a couple of, we'll talk about this briefly. So follow with me. How do we show what happens when chemical changes occur? And so the question really is, Mr. Woods, so how do molecules happen in the first place? How do molecules occur? Because you have atoms all over the place, but how do molecules occur? And here's basically what happens. A catalyst or one element gets combined with or comes into contact with another element, and then there are reactions or chemical changes that occur when elements come together. So what we're really talking about when molecules form are chemical changes that occur when atoms of different elements come together. So let's read this. Sometimes matter can go through a change. One type of change is called a chemical change. So let's just kind of get that circled right now. Chemical change. So when matter goes through a chemical change, its particles or atoms actually break apart. They break their bonds to other atoms, and they rearrange themselves to form a new type of matter. So let's get our green marker right now, and let's get this marked. So when matter goes through a change, and especially if we're talking about a chemical change, okay, and then we're going to kind of jump right down to here. Its particles or atoms actually break their bonds, or they break apart and rearrange themselves to form a new type of matter. Usually many times a completely different substance. So let's just get this linked to chemical change, okay? So chemical change, and we're really, this is, we're over here. Remember, this kind of goes over into this other side right here and comes in. So those two words go together, chemical change. All right, so let's finish this paragraph, and then I'll show you what I mean. For example, when the compounds carbon dioxide and water, which we see down here, so this is carbon dioxide, CO2, this is the carbon atom, and these are oxygen atoms, okay? So when the compound carbon dioxide and water, which is H2O, so here's oxygen, and this is a hydrogen atom, and this is a hydrogen atom. So when these combine together in a chemical reaction, a new compound called carbonic acid, H2CO3, is produced. Carbonic acid is what is in cans of soft drink or bottles of soft drink when you pop the tab, or when you open a bottle and you hear this. Okay, that's actually carbonic acid being released, and well, it's actually carbon dioxide being released because carbonic acid has been added to the soft drink. So get your blue marker, if you will, please, real quickly. Let's get blue, because there's a main idea down here. So chemical changes are written in the form of chemical equations. And we're going to kind of look at this in two parts. So, and then go ahead and get your red marker again, because we have this chemical equation is a key word. So let's just circle chemical equation here, and then get your green, and we'll just we'll put a little understanding right here so we have some sense of what it is. But we're going to look at chemical equations in the next video clip. But basically, a chemical equation, this shows what happens when elements combine. And elements, the elements, when we're actually looking, and you'll see this a little bit later, but when we actually are looking at elements and they're combining, we call them actually reactants. So like if I was going to put this with this, if I was going to put carbon dioxide into water, and by the way, you could put carbon dioxide into water if you had it in a compressed gas, like if you guys have ever played paintball, or if you have a BB gun with a little CO2 cartridge. Okay, that's carbon dioxide that's compressed into a little canister or container, and then you can release that carbon dioxide with a valve. So that's one way you could so you could take carbon dioxide, a canister of it, and if you had a little valve, you could like put it down into water, and you could kind of bubble carbon dioxide into water, and you could make carbonic acid that way. Or, I'm not sure how many of you realize it, but dry ice is actually carbon dioxide, but it's carbon dioxide in a solid form. Carbon dioxide, when you use it in a paintball gun, or if you use it in a little canister and you're going to spray it into water, that's carbon dioxide as a gas. But carbon dioxide can also be in its solid form if you can get carbon dioxide cold enough, and I think that's like somewhere around 78 degrees Celsius negative. So really, 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 really cold. The chemical equation, we're going to write a chemical equation, and we're going to look at it in the next video. But chemical equations show what happens when you combine elements, or when you combine molecules of different compounds. In the rest of this video, we're going to take a look at the chemical change that actually occurs. And let's take a look at these. So here we have carbon dioxide, and this would be CO2. And over here we have water, which is H2O, 2 hydrogens and an oxygen. And let's just look at the 3D renderings of these, see if we can get them to come up. Here comes water. Move water over here, and let's see if I can get... And there's carbon dioxide. And so we see these two, and let's go ahead and look at the way they're actually bonded. Take a look at the way these are actually bonded. So we actually see carbon in the middle here bonded to hydrogen, or bonded to oxygen with double bars. So there's some sort of a double bond there. And then we see in water, of course we know this molecule, we see water bonded to the 2 hydrogens in a single bar, or a single bond. So so let's just take a look at what happens when we put these together. So if I break these apart, and I break these two guys apart, what we find that I'm going to kind of rearrange them like this. Okay, we find that oxygen wants to, and let me just show you this so you can actually see what's going on here. If I try to bring oxygen together like this, so if I try to bring water or carbon right into water, they will join, but they don't make carbonic acid in this way. So what's up with that, Mr. Woods? Well, let's watch. Let's have hydrogen separate from oxygen first. Remember, when chemical change occurs, the molecules actually break their bonds and they rearrange themselves. So let's just see what happens if I bring oxygen in here first, and then I bring hydrogen in, and I bring hydrogen in, Now hydrogen has joined to the 2 oxygen atoms that were already joined to carbon. And this oxygen atom that was with the water has released the 2 hydrogens. Those 2 hydrogens, this hydrogen went over to this water, or to this oxygen. This hydrogen went over to this oxygen. And now we have carbon bonded to 3 molecules of oxygen with no bond. Well, with the hydrogen only bonded to oxygen and no direct bond between the hydrogen and the carbon. And take a look at this 3D rendering. Take a look at this model. And then we'll actually put this up with the ball and stick. And you're going to actually want and look at how strange what has actually happened. You remember originally carbon was double bonded to its 2 oxygen atoms. It was double bonded to its 2 oxygen atoms. And when we brought 2 hydrogens in toward the oxygens, they took one of those bonds from carbon and stuck it over on the hydrogen. So one of these 2 bars that was originally between carbon and oxygen, one of those bars, one of those bonds has now gone over to the hydrogen, and both of those. And look what carbon did with the new oxygen atom that came in. It went ahead and created a double bond with that oxygen atom. So there's a very specific way that atoms will come together when we start thinking about how these molecules form. Now, you guys don't have to remember all these little details about how many bars, what happened when they joined. What you do need to remember is that there are certain ways that the molecules are structured. And you know, we don't have to memorize these. We would use an atom builder, or we would use a simulation if we wanted to look at them. You're not going to remember all the different ways that compounds form or the chemical changes that occur. But what we do need to realize is that when different molecules come together and in a chemical reaction, and there's going to be a chemical change, oftentimes, most times, the particles of this, of each molecule will actually break apart. They'll break the bonds, or they'll rearrange the bonds so that the bonds are different, so that the way they stick and the way the atoms actually arrange themselves in the molecule are sometimes they're different. Many times they're different than the original bonds were, and you actually wind up having a completely different substance. And we're going to take a look at what happens in a chemical equation. And so you may want to rewind this, pull this video back to where the marking was if you didn't get it marked to begin with. And you might want to actually just watch this video again and listen to some of the things that I was talking about with respect to the molecules and how they come together. But get this marked and then finish it up. And then we'll take a look at the next paragraph. So this was paragraph 12, and we're going to take a look at paragraph 13.